Well, good morning again. We're still before, got the same shirt on. By the way, my shirt says champion volleyball player. I really don't know how I got this shirt because I don't play volleyball ever. Um, However, we're going to be looking at 5.5, I guess, is the next thing. Now, what you see on the screen is 5.4 homework. And you can see all the answers here. So if you need them, you could pause them or something. I'm just going to scroll down at this point. There you go. That's probably good. Here, let's get them all. Yeah, that's probably good enough. Sorry to make your eyes go crazy. But that's all of them. I worked one out down here also. So I will show you that. So you can pause the screen, check your answers. All right, here's one that I worked out, I think 57. So you can see I set the u equal to sine x plus cosine x. Um, that's how I worked it. Anyway, this looks crazy, but I'm sure we'll talk about it in class. Let's get to the nitty gritty. Let's get to 5.5. So every base I've been talking about has been the natural log or e. All right? But now we're going to talk about a base that's other than e. For example, if this was e based natural log a times x, it would just be a to the x. You learned back in pre-calc, maybe algebra 2, that if you have a change of bases, so you have log base a of x, so like log base 5 of something. So you're going to take the natural log of x over the natural log of a. You probably learned that you take the log of x over the log of a. Both, it doesn't matter. I put a little or here. It doesn't matter. As long as you change the bases to a single base. So that's what you probably learned. All right? Hasn't no calc yet. Some properties that you learned. Here's your fish hook, your classic fish hook. Okay, a log a of x is x for all x greater than 0. Log a of a to the x is the x. It just remember, if you log a something with a to the x, you always get the exponent. Okay. So let's play with these properties real quick, to show you that I'm alive. We got 3 to the x equals 1 over 81. If we want to solve for x and x is in the power, then what I'm going to do is I'm going to do log base 3 of that, so that becomes x. So I'm going to do equals log base 3 of 1 over 81. Well, 81 happens to be a 3 to the negative 4 power. I think you would recognize that. I would hope that you would recognize this. And then you would get x equal to just negative 4. Because these guys will undo each other. Okay? That's just old school stuff. Reminding you, sort of, because people will say, well, I don't remember how to do that. And that's okay. This probably doesn't get done over the Christmas break or the holiday break. So this one, a little easier. You would fish hook this one. And you'd say 2 to the negative 4 power equals x. So then we would say that x equals 1 over 16. Remember, 2 to the negative 4 is 1 over 2 to the 4th. These guys are the same. And then that's how I get 1 over 16. So that's just a recap of these properties. And you might say, well, why do you recap these properties? As you saw the other one, or as you saw with the natural log, sometimes the properties will help you get the derivative a little quicker. Speaking of derivatives, let's talk about them. Here's things you have to know. You must either know them, memorize them, I don't care. All right? But know them. Because this is what's going to separate you from other calc people. Because they're not going to memorize this. All right? And they're not going to know that a to the x. Remember, that's like 5. This is like 5 to the x power. That's what we're talking about here. When we take the derivative, it's the natural log of 5 times 5 to the x power. And if it's u, it's the same thing, just multiply it by the du dx. The derivative of the natural log of any base of x. Okay, I said natural, I misspoke. The derivative of a log base anything of x. So base 10, base whatever, is going to be 1 over the natural log of whatever the base is times x. Next one is just the du, because if you multiply it by du. That's all. All right, let's try a few. Find the derivative. And this is one to give you on an AP exam. All right, or I'll give you one on a quiz, and I'll say y prime is equal to, well, I'm just going to use that rule up top. It says natural log of 2 times 2 to the x. Done. That's it. So if you know the rule, you're pretty good. This one a little different because now we have a du going on here. So it's going to be the same thing. Natural log of the base times the 2 to the 3x, but don't forget to multiply it by du. That's the only difference between these two problems. Du is 3 when I take the derivative of whatever power that is. And that's what I get. I'm leaving it like that. Here, I don't like the dot, maybe I'll do that. All right, whatever you like. You like a dot, you like parentheses, whatever you like. This one, I circled the 10 because a lot of times you won't see 10. All right? It's understood if you see log that the base is 10. The other ones are the bases that come up. All right? So if I remember this one, it's y prime is equal to 1 over natural log of 10, okay, times cosine of x. But then, wait a minute, this is a u, so we have to multiply by du, which is negative sine of x. All right, we have to multiply by this du thing here. So I'm going to make it look nicer, okay? It's going to look like this. Negative sine of x over ln of 10 times cosine of x. And all that is, really, is negative tangent of x over ln of 10. That's what it would look like in the back of the book. That's what it would look like on the AP exam. All right? So, do these come up a lot? No. All right? They don't. But like I said, these are what separates maybe sometimes a 4 from a 5. So knowing this section really helps. Check these out. I got to check these out here. The derivative of e to the x, is e to the x. Okay, that's no problem. Look at this. X to the e. Well, the e is a number. So I could take the regular power rule and say e to the x to the e minus 1. Right? If it's a number, it's no problem. Look at this one. This is just a number. It's a number to a number. When I take the derivative, it's 0. Little crazy stuff here. Okay? Sometimes we get bogged down. Now, this next thing right here is a special case. I call it the u to the u. Take the ln of both sides. Whenever you see that, whenever you see an x to an x, or some function, cosine to the cosine function, cosine to cosine, sine to the sine power, we're going to take the ln of both sides. So I'm going to get the ln of y equals the ln of x to the x. Now, why do we do that? Well, that is to break this up and bring this back out in front. That's why I want to do it. So I get the ln of y equal to x times ln of x. Now I can go ahead and I can try what I can try here. I get y prime over y. That's the derivative. Now I'm taking derivative of this blue stuff, okay? Now I take the derivative of this side. Remember, it's a product rule. So it's first times derivative of second, which is 1, plus second times derivative of first, ln of x. So now, this turns out to be y prime equals the quantity 1 plus ln of x times y. We'll bring the y back from the original. The original was x to the x. So this final answer with all x's in it would be 1 plus ln of x times x to the x. That's what it would look like. All right? That's it. But remember, this is an important little Marashio tip. It's nice is what it is. If it's u to the u, we're taking the ln of both sides. So you might say, well, what prompted me to do that? That does. All right? Uno más, por favor. Well, maybe 2 more. You know, 1 means 2, Kyrie, right? All right, here we go. No, it's 1 more, actually. So I've got this. And if I'm right, This guy is thinking back to looking. Whoa, this. Oh, I've got this. 3 to the x over ln of 3 plus c. Oh my god, it can't get that easy. You know what? It is that easy, but you just gotta remember this, which is not the easy part. All right, let's do it. Let's do one more. Let's do here. I'll put it in black. So once you go black, you know what happens. Let's go 3 to the 2x dx. So now the power obviously is a little different. So what I'm going to do is I'm going to set the u equal to 2x. Therefore, the du is 2 dx. So now if I put a 2 here, I can do 1/2 out here. So now I get, when I go to look at this, it's 1/2 the integral of 3 to the u du. Now it's going to look like the top. Now it will look like the top. So it'll be 1/2 3 to the u up top times 3 to the u up top ln of 3 on the bottom. All I gotta do is replace the u and I'm done. All right, don't forget your plus c. Just replace the u and I'm done. So it's 3 to the 2x all over 2 times ln of 3 plus c. That is the answer to that black original problem. Using, by the way, using that. All right. So that's integration of bases other than e. And it gets a little silly. I like e. You're starting to like e better. Me too. Lastly, just some limit I found involving e. Just says as x goes to infinity, 1 plus 1 over x to the x power equals limit to infinity. So anytime you see this, you can say that's equal to e. Or the other one likewise. Comes in a little handy. I mean, might be good for a problem. You know, might be good for a pickup line. Who knows? Anyway, got you some homework here. Not a lot. Got about 10 problems here. Page 368, 41 to 50. All right. We'll go over those in class. We'll do some more in class. This will be happy stuff. Anyway, the good news is we only have about one or two sections. We only have one section left. It's a two-parter, but we have one section left. Maybe it's two. Maybe it's 2 sections left. That's it, of Chapter 5. So we'll be done with Chapter 5 quickly. Anyway, enjoy break again. Happy New Year. You might be actually watching this when we come back, so it might be way back after the New Year. So enjoy.